In this video, we're going to be taking a look at a basic RC circuit, which has two resistors and a capacitor. The first question we're going to answer is, what's the current and voltage drop through the resistors immediately after the loop is completed? So say, for example, there was a switch in there or the voltage source need to be connected. So immediately after that connection, and then also after an extended time period where the current was allowed to flow for a bit. Also, what is the eventual charge of the capacitor, the Q value, and what do the voltage drops look like graphically over this time period? That's for the resistors and for the capacitor as well. Now, what happens initially is once everything is hooked up to the 12-volt source, the charge starts flowing around clockwise in our circuit. And what happens is it goes from high potential to low potential over here, and then eventually there is no potential difference, and then the current stops. So the immediate result is that we have a regular series circuit to begin with, which means that there's a total of 6 ohms of resistance because the electrons go through a 4 and 2 ohm resistor. So we have a total resistance of 6 ohms. And we know that the total voltage drop is 12 according to our picture. So if we do Ohm's law and do voltage divided by the total resistance, then we have a current of 2 amps. Now that 2 amps is going to be the same amount of current that's flowing through each of the resistors. So if we wanted to find the voltage drop, all we have to do is V equals I times R. The voltage is current times resistance, so 2 times the 8 ohms, which is going to give us an 8-volt drop, and then the 2 times 2 ohms, which is going to give us a 4-volt drop for that total 12 voltage drop. Now, after an extended period of time, what's going to happen is there is going to be no potential difference or flow of current. So the eventual change is going to be the current is going to go to 0. And then if the current is going to go to 0, then our 2 resistors are not going to have any voltage drop. So these 2 are eventually going to go to 0 as well. Now let's go ahead and take a look at our capacitor. Now our capacitor is eventually going to have a buildup of charge, and that is going to create a negatively and positively charged conductive plate on each side. And the eventual charge is going to be calculated by Q equals C times V. The capacitance is 2 microfarads. And then the voltage that eventually gets is 12. So it's going to be 24 microcoulombs as our final answer for how much charge it gets. Now what happens is, as this side develops more and more charge, that potential difference goes from 12 to 0 eventually, and then the current is going to stop flowing. So let's talk about what the 2 graphs would look like. So it says, what do the voltage drops look like graphically over this time period? Now, for the voltage of the capacitor over time, what it's going to look like is it's going to get exponentially larger and then start to level off at the end. Once this has a greater buildup of negative charge, its ability to collect electrons on that plate is going to be less and less until it's basically 0, and then that's going to level out. Now for our voltage drop of our resistors, it's going to have the opposite effect, where it drops down dramatically in the beginning and becomes less and less and less until it eventually hits 0, because as this plate collects more and more charge, that potential difference is going to drop to a lower and lower number until there is no current and no voltage drop through each of the or across each of those 2 resistors. I'm going to fix my curve here a little bit, but it's basically an inverse curve over here. Okay, so when taking a look at a basic RC circuit, there is kind of like an initial flow of current that goes through, but then as that potential difference changes and it decreases, the flow of current becomes less and less until there is no flow of current, and then that capacitor reaches its maximum charge, which is that 24 microcoulombs based on its capacitance and the voltage source. And then we have the two different changes in voltage based on if you're taking a look at the capacitor or the resistors as shown by the green and blue graphs. So I hope that was helpful in helping you understand the basics of an RC circuit. Thanks for watching and listening.